the inferior. Okay? According to Ohm equation, current equals to voltage difference divided by resistance. Okay? In nerve, we need signal conduction from body to end or from end to body. We need nerves for signal conduction. Okay? This signal conduction is an electrical change on the membrane that produce current according to Ohm equation. More voltage difference, more current. More resistance, less current. Okay? No, okay.
وصلت الفكرة ولا لا؟
This locally produced depolarization called local potential. This locally produced depolarization or repolarization, local change called local potential. Local potential can spread all the membrane because both intracellular and extracellular are conductive tissue, conductive environment. Okay? But we have a problem. Conduction of local potential cannot move a long distance. In a less than 1 millimeter distance, the amount of depolarization decreases to 0. And 1 millimeter later, we don't have any depolarization. This conduction is decremental. Decremental. عربیش میشه توی کارشی decremental. تقلیدی. تقلیدی. Decremental. So we cannot transport local potential by the nerve. We need other phenomena. According to channels that open on the cell membrane, we may have a positive local potential, depolarizing potential, or hyperpolarizing local potential. Positive local potential called EPSP, excitatory postsynaptic potential, and negative one called IPSP, inhibitory postsynaptic potential. This local potential spread out of the site of production, but the propagation is decremental. The amount of the voltage decrease and decrease to the resting membrane potential. For example, here, the polarizing potential changes the membrane potential to minus 55. It's spread all around and decrease to minus 60, minus 65, minus 70. The resting membrane potential. In a short distance, the local potential disappears. Cannot move in a long distance. Here you see by curve this phenomenon. Here we have a high voltage change. Then during the spreading, the amount of the voltage decreases to resting membrane potential, called decremental conduction or cable properties. For what reason the amount of local potential decrease? Here you see the electrical model of membrane. The lipid bilayer is a dielectric substance, and extracellular fluid is a conductive. مایع خارج سلول حاکی رسانه رو در حالی چی میگن؟ رسانه. Extracellular fluid is conductive, intracellular fluid is conductive, and a dielectric between them. موصل
كهربائي.
موصل
موصل كهربائي.
ممثل extracellular fluid is موصل, intracellular fluid is موصل, and the cell membrane not موصل, غير موصل. آية غير موصل. آية عربي
زورق.
آية آية It produces a capacitor. And each conductive substance have a resistance. This voltage difference, this local potential, when spread, should first charge the capacitor and used by the resistance in the cell and resistance outside of the cell and resistance across cell membrane. We have three resistance. So the amount of the polarization decreases to the resting state.
فهي همون ورود آیون بعدها potential ایجاد الدكتور يقول اللوكال بوتنشال ما يقدر ينتشر، ما يقدر يؤدي البوتنشال نفسه مال الخلية، اوكي؟ لأن عندنا ريزيستنس بداخل الممبرين قبل بالاكسترا ابر ريزيستنس، لازم يغلط هاي الريزيستنس يلا يقدر ينتشر، ولهذا السبب الريزيستنس اللي موجودة ما يقدر ينتشر حتى واحد من مثل أو أقل. ينتشر وحي بعد ما يسوي البوتنشال نفسه اللي يسويه في الخلية لما يدخل الآيون. فاللوكال بوتنشال الانتشار معناته كلش قليل، ما ينتشر وما يؤدي البوتنشال اللي تريده الخلية.
شو بس عندي سؤال، يعني هسه انا سمعت من الدكتور انه كانه الخارج موصل والداخل موصل، هذا الغشاء الخلوي صار مثل
غير موصل.
غير موصل، صار هنا صار مثل المتسعه، احنا درسناها طبعا، متسعه على جانبين الشحنات، تمام؟ و الار اللي هي المقاومه تمثل مقاومه هاي الغشاء لعبور الشحنات، تمام؟ زين انا بس سؤالي هو يعني شنو الفائده من هاي الشحنات المخزنه؟
اكشن بوتنشال لما يكون الخلية يلا تؤدي عملها. الخلية مثلا سيجنالز بداخل الخلية، تبدا سيجنال بداخل الخلية حتى تؤدي عملها. كلها هاي في الاكشن بوتنشال، الاكشن بوتنشال اذا ما موجود الخلية ما تشتغل. فدخول الايونز داخل الخلية راح يسوي ديبولاريزيشن، الديبولاريزيشن نفسه راح يسوي سيميليشن.
بوتنسيال عملها بفتبو.
بله همون میگن چیه گفتم الان توضیح میده كل سلول نیاز داره به این. كل الخلية تحتاج لهذا الشيء حتى تشتغل. هسه راح تشرح عليه الدكتور الاكشن بوتنشال كامل.
اكسايتد ريزيستنس فقط سلول تعريف This metal شو اسمه كده؟ سيم فلزي وش ممكن
سيم فلزي.
Sim is conductive for temperature. Okay? Here is very hot, and this is conductive, but I don't sense any temperature here, because the conduction is decremental. The temperature decrease here. It means decremental conduction. The local potential also like this. We have a 30 millivolt local potential. When during a spirit, the amount of during propagation, the amount of the voltage decrease to the resting state. Because the conduction is decremental. With decremental conduction, we cannot send signal from the spine to toe, a long distance, because local potential only can move less than 1 millimeter. After that, we don't see them. Completely removed, according to decremental conduction. Okay? Here, the sim coated by a special compound, a phosphate compound. We apply heat. We applied heat here and nothing occurred. But after a time, اشتعل هذا المكان. We need a minimum temperature for اشتعال. میگیم آستانه اشتعال. The threshold for firing. We have a minimum temperature to firing this side. The threshold. Then we have the fire. For example, we need 200 degrees centigrade for firing, the first firing. After firing, this substance produces about 1000 degrees of Celsius. A high temperature. We cannot touch it. This temperature, high temperature, activates the adjacent substance. The adjacent substance for firing needs at least 200 degrees centigrade. Okay? We have 1000 degrees. So the adjacent side become fire. Okay? And the adjacent side stimulate the next. And next, like the دو امدادی روش چی میگه؟ دو امدادی میدوان میده چوبه بعدی.
الرياضة اللي يربطون ينطون قطعة اللي شنو اسمها؟ تابع؟ ينطون قطعة للشخص اللي قدامه حتى يكمل السباق.
The amount of heat produced here at the beginning side is equal to amount the temperature in all the way to the end. Anywhere we have this coating substance, this phenomenon can be moved to here. At this side we don't have this coating, so the phenomenon stops. Okay? The local potential cannot move in a line distance, only less than 1 millimeter. For a line distance, we need a new phenomenon, like this. A regenerative, self-productive phenomenon. Regenerative phenomenon. Self-productive phenomenon. یه چیزی میشه خود تولید کننده. خودش ایجاد کنه.
من نفسها هي نفسها. فنومن ظاهرة معناها.
Self-producing phenomenon. Okay? Action potential is a self-producing phenomenon. Like the example. One action potential produced in a side of the membrane. This action potential stimulates all adjacent around. And the new action potential similar to that produced. The second produced third, third produced fourth, fourth produced fifth. Go on to the end. Action potential only can produce in a special part of membrane, not in all membrane. Our cells divided in two types, excitable tissue and inexcitable tissue. Excitable tissue are nerves and muscles. Excitable tissue are nerve and muscles. Other tissue aren't excitable. Kidney, liver, bone, and other tissue are not excitable. Only nerve and muscles are excitable. In some part of the membrane of the excitable cells, in some part of the membrane of the excitable cells, the action potential may produce. Not at all part of the excitable tissue membrane. So, non-excitable cell cannot produce action potential. خلاص. In excitable tissue, in a special part of some part of the cell membrane of them, maybe action potential can be produced. In other part, not. Action potential produced only in the cell membrane that the special instrument for production of action potential. Action potential only produced in parts of cell membrane that have the special instruments for production of action potential, not in all parts. For example, in a neuron, in a nerve cell, the cell body cannot produce action potential. The nerve terminal also cannot produce action potential. Only the axon can produce action potential. In here, we don't have any action potential. And here also, we don't have action potential because the instruments need for action potential مفقود. مفقود درستی یا مفقود. And هنا أيضا مفقود. From here, in the beginning of the axon, initial segment or axon hilak, initial segment, the action potential can produce and going to here. In this site, we don't have action potential. What's the difference between this membrane and here? It's in two parts. Here we have some channels that they aren't here. The instruments for action potential are some special channels. What are these channels? میشناسن چه کانالایی نیازه؟
شنو القنوات اللي تحتاج الاكشن بوتنشال؟ يعني الدكتور اكو انسترومنت خاصه بالاكشن بوتنشال موجوده في الاماكن المحدده للخليه هي القنوات الصوديوم بوتاسيوم
Activation gate.
قنوات حيوانية يعني.
Activation gate.
channel. We have leak channel, gated channel. Leak or gated, gated. لماذا? Sometimes open, sometimes not. Gated channel divided to voltage gated, ligand gated, stress gated. Which of them? Voltage, ligand, stress. Which of them? Voltage. لماذا? The phenomenon is electrical. The stimulus is electrical. Changing in electrical potential should open or close the channel. So we need voltage gated channel, not ligand gated, not stress gated. We need gated channel and بينهم voltage gated channel. Two voltage gated channel needed for production of action potential. And in some situation, we need a third one. At least we need two voltage gated channel. One, potassium gated channel, voltage gated channel, and one sodium voltage gated channel. In the cell membrane of excitable tissue, in the site that action potential should produce, we have these instruments, these channels, voltage gated channels. Sodium voltage gated channel called rapid sodium voltage gated channel. Rapid sodium voltage gated channel is present in the cell membrane. At this site. Each voltage gated channel have a threshold for stimulation, for opening. Each voltage gated channel, it has a threshold. Like the example, we need a minimum temperature for starting the phenomenon. Voltage gated channels also have a threshold. They need a minimum voltage to open. Each channel has a threshold.
NA voltage channel.
Voltage gated channel, NA
NA.
voltage gated channel. Each channel have a threshold. For example, in this membrane, maybe sodium channel's threshold is about -60. -60 millivolt. The resting membrane potential here is -70. We need 10 millivolt depolarization to reach the threshold. From -70 to -60. At least we need 10 millivolt local potential. Local potential with amplitude of 10 needed at least to stimulate the sodium channels to open. Opening sodium channels in this membrane increase permeability to sodium several thousand times. Opening of sodium channels in this membrane increase permeability to sodium several thousands times relative to resting state. In resting state, permeability to potassium is 100 times greater than sodium. But after stimulation and opening of sodium voltage-gated sodium channels, the permeability to sodium will be increased several